I'm Charlie Seibel. Today is June the 13th, 1990. The following presentation shows the history of the Seibel helicopters. There were 6 models. The S1 and the S2 were design concepts. The S3 was a single-place experimental helicopter, and the S4 series were 2-place helicopters. My interest in helicopters started while I was a student in the California Institute of Technology. I entered Caltech in the fall of 1938 and pursued a course of general science for 2 years, at which time I entered the engineering school. In 1942, I graduated with a degree in mechanical engineering with an aeronautical engineering option. During my graduate year, I continued my training in aeronautical engineering and picked helicopters as my specialty. The logic in picking a helicopter field was that it was just starting and I was just starting, so I would have an opportunity. During my graduate year, my thesis was concerned with basic helicopter theory with some analysis of stability and performance. It was at this time that I came up with the idea for the Seibel S1, which was a tilt-rotor helicopter airplane. We'll talk to this more. Early in 1943, a student friend of mine informed me that there was a man on campus recruiting for student engineers that had recently broken his arm flying a helicopter. This was the first clue I had that Bell Aircraft was in the helicopter business. I met with Bob Stanley, who at that time was chief test pilot, and accepted the offer he made to go to work on their helicopter program. I joined Bell in June of 1943, and at that point in time I had pursued the S1 design, the tilt rotor, to the point where I wanted to go ahead and get a patent on it. Getting a release from Bell was no problem because I had the idea prior to joining Bell. I'll read from the description of the patent. This invention relates to the improvement in a heavier-than-air aircraft. The object of the invention is to provide an aircraft similar in appearance to the conventional airplane, but in which the propellers are carried at the outer ends of the wing and may be rocked from a horizontal position to a vertical position, so that as the propellers revolve, they will first serve to lift the aircraft vertically, and then by gradually rocking the propellers forward, they will provide the forward propulsion, at which time the wings will function in the normal manner to lift the aircraft. Figure 1 shows the propellers in the horizontal position for landing and takeoff. Figure 2 shows the propellers in the vertical position suitable for forward flight. We will now quickly scan the other patent drawings. The control system employed cables and pulleys. The vertical engine drove through spiral bevel gears and shafting to the 2 propellers. The control system for directional control was combined with the lateral and longitudinal control. On the front of the engine was located a centrifugal clutch, a freewheeling unit, and a gear shift to allow the rotors to be turned slower in forward flight. The non-rotating control system contained swash plates, one of which was rotated during conversion to properly phase the control between airplane and helicopter. My Buffalo, New York patent attorneys informed me by letter on March the 27th, 1944, that they had filed the patent with the Patent Office. For the preparation of 41 pages of specifications for 20 claims and the preparation of 9 sheets of drawings, I had spent a total of $289.75, which was more than my monthly salary at that time. I decided to discontinue the tilt rotor program because of the unaffordable cost, and also the fact that I began to realize that what was really needed was a simpler helicopter, not a more complex one. The S2 model was a coaxial design study, and this too proved to be too complex, so it was shelved quite early. The S3 was an all-out effort to make a simplified helicopter. But before continuing with that, we'll return to the Bell Aircraft program. During the 1930s, Arthur Young did an extensive free flight model development. As soon as the models attained flight, they would demonstrate immediately the instability of the helicopter. After a long development, this was the final model, which was controlled remotely, was perfectly stable, and was the sales tool that Arthur Young used to convince Larry Bell that he should develop a full-scale helicopter. Arthur Young, here on the left, was very much an innovator. He's on the right here with Bart Kelly in the center and Ed Cook on the left. It's through his innovation and being a very practical designer that the Bell helicopter came into being. There were about 30 technicians in the group, all located remotely at Gardenville, New York, away from the main plant. We spoke earlier of the Bob Stanley breaking his arm in a helicopter, and this photograph was taken in January of 1943, just 3 or 4 days before he hired me to go to work on the helicopter program. It wasn't a very good day for a pilot inexperienced in helicopter flight to be trying his initial flight. But he was in a hurry to do it and leave town. And here we'll see him go up through the main rotor and be thrown out into a snowbank. Indeed, very fortunate that the only injury that he suffered was a broken arm. The spider legs on the helicopter provided the maximum ground stability and were ideal for a new pilot to learn to fly the helicopter. Here he goes through the rotor. By the summer of 1943, the test aircraft had been rebuilt. Floyd Carlson was assigned to the program as a dedicated pilot and quickly mastered the art of hovering the aircraft on the spider legs. He attempted forward flight, and as he reached speeds of about 25 miles an hour, a severe 2 per rev vibration set in, forcing him to discontinue. Art Young asked me to investigate the possibility of the downwash distribution across the rotor from front to rear, causing a drag variation in the blade and creating this vibration. With reference to an NACA test report 536, I was able to come up with a confirmation of this and show that it should reach a maximum at about 25 miles an hour. Floyd then made the attempt to push on through and found that at higher speeds the vibration decreased, confirming the analysis. The analysis was conducted in 1943, of course, but in 1944, October, a work was published in the journal Aeronautical Sciences. This chart shows the downwash and distribution of the downwash at various forward speeds. Flight is from the right to the left. You notice the upper left-hand diagram shows a uniform downwash for 0 forward speed, and then as we increase speed, we find an increase in downwash distribution. As we go on out beyond that to higher speeds, due to rotor inflow, it becomes more or less uniform again. The bottom diagram shows the drag increment between the front blade and the rear blade as a function of forward speed. You notice that it reaches a maximum at about 25 miles an hour and then decreases with increased speed. It's also shown to be only 10 pounds, which isn't a very high force. However, on this program, Bart Kelly conducted a parallel program on analysis of the dynamics of the helicopter and determined that the rotor was in resonance in the plane of rotation at the frequency of twice rotor RPM. And this impressed force with this resonance was causing the severe vibration. To increase the stiffness of the rotor in plane, Floyd Carlson suggested we install a tubular yoke shown here on the rotor with uniball bearings at the ends to allow the blades to change pitch. With this installed, the vibration subsided and we had the solution. Of course, late 43, Ship 1 was dressed up a bit with the wheel landing gear and the spider legs removed. You'll notice that the main rotor still had the brace on it, which was known as a Swedish yoke, since Floyd Carlson had to come up with the idea. By this time, Floyd was getting to be quite proficient in this helicopter, and later developed the technique for auto rotation using this machine. And in that case, the landing gear proved to be inadequate. The second Model 30 was rolled out later, and it differed in being a two-place. The smoke coming out of the tail boom is due to the exhaust augmented oil cooler that we tried on this. Each machine had different experimental things on it, and this two-place, of course, provided the opportunity to give some rides in the helicopter. Larry Bell was the first official passenger, although of course Floyd had tried it previously with other people. This is ship number 3 with Joe Mashman flying it. All of these are Model 30s, but they're all different. My first helicopter ride was in ship number 2, Model 30, Floyd and I, and with a 165 horsepower engine, this was about all the weight that this machine would lift. You notice it also has the yoke up here on the rotor. Later rotors, of course, were designed with more hub stiffness so that it was a temporary fix. Model testing continued to be a big part of the Gardenville program. This is an electric-powered flying model, stabilizer bar, and it had a swash plate for 4.5 control. The lateral and directional controls were not required because it was flown as a U-control model in a circle on a cable. The power was supplied by 220 volts and through a rheostat so that it could be modulated to increase or decrease power. It was always flown in forward flight in a circle. In fact, the program here was directed toward measuring the forward flight performance and correlating it with calculations. At that time, we didn't have a full-scale machine to use. This is Arthur Young in the front, Ed Unwin, and Tom Harriman. Tom's recording the electrical data, and Ed was measuring the speed with a stopwatch. Now, I never did get to fly a full-scale helicopter, but I got to be quite proficient with the model flying. An accident like this, of course, is much better in the model than it is in the full scale, and we always had a number of them. But from each accident, you usually learn something. Maybe it's just how to do a better job of flying, but it's always a lesson. Here we put on a streamlined fuselage in an attempt to reduce drag and evaluate how much good it would do. It didn't do much good because of the drag of the rotor and the landing gear and the cable, so there wasn't a significant increase in speed with the faired fuselage. These models were powered with a 1/2-inch Black & Decker drill motor, which is designed to run on 110 volts, and we ran it on 220. Here's a vibration problem in the model, which we could get a better picture of by shooting some slow motion movies, which were always very helpful even on full-scale helicopter problems. In 1945, the Gardenville group moved to Niagara Falls. In the meantime, the engineering department at Niagara Falls had designed a Model 42, which we see here. Here's a Model 42 hovering in front of the Niagara Falls plant. Only 3 of these aircraft were built. This is Dick Ledwin and I standing by the Model 42 tail rotor test rig. Dick and I have been together through our complete careers. He's an expert in any kind of shop work, holds an A&P license, is a good supervisor, and we've stuck together at Bell and Seibel Helicopters, Cessna, and back to Bell. When the Gardenville group moved to the Niagara Falls plant, I moved to Kenmore, close to where Dick was living, and we decided to proceed with the manufacture of the S3 helicopter. I rented the upstairs of a duplex, and the owner who lived below agreed to let us use the attic as a shop. So with very simple tools, we set up shop, and in that attic shop we manufactured the main rotor blades, the tail boom, the complete tail rotor and tail rotor gearbox, and we bought the engine and the gears for the transmission, which all was shipped to Wichita later on. In our attic workshop, this is a glue fixture we used for the main rotor blades. The blades were laminated with equivalent strips. Say number 1 strip in the leading edge of each blade was taken from adjacent sections in the same board. They were laid in here with casein glue, and then the wedges were driven in to provide the clamping pressure. In order to move the blade section center of gravity forward, balsa wood blocks were glued to the trailing edge at the tip of the blades. Also, there were metal steel inserts shown on the left that were put into a slot within the blade. Dick Ledwin cutting the blade down to contour with a wood plane. It was all done by hand with templates. The finished main rotor blades are shown here supported on a couple of chairs. Notice the mid-span balance weights that protrude forward from the leading edge. Here's the finished tail boom, tail rotor gearbox, and complete tail rotor. A flying model was constructed and flown in the attic to to test the new concept of longitudinal lateral control. The model was tethered with an arm that extended to the right and was pivoted at the end, so the control was only on one axis. The transmission gears were from a 1-ton Ford truck rear end. Having made good progress on the S3 components, George Lubin joined our group. George, nicknamed Red, he had extensive helicopter mechanical experience for the day. He had worked for Sikorsky on his early program, had been a mechanic in the Coast Guard at Floyd Bennett Field, and was at Bell Aircraft with us. In the fall of 1946, I resigned from Bell and moved to Wichita. We shipped the parts to Wichita, and I took a job with the Boeing Airplane Company as a meal ticket as project aerodynamicist on the L-15. Dick remained in Buffalo and, working for Bell, continued to make parts for the S3 helicopter. In January 1947, Red moved to Wichita and went to work full-time on the project. Full-time was about 80 hours a week. My 80-hour week was divided between Boeing and the project. During the first half of 1947, the fuselage structure, cabin structure, landing gear, and engine mount were all manufactured and assembled in the basement. Bolted joints were required in several locations to assure that the components could later be removed from the basement. This is a photograph of the fuselage structure and the cabin structure with its support. In the rear there were two tension members, in front a compression member, and these allowed the cabin to move fore and aft and laterally for longitudinal and lateral control. The torque restraint and yaw was through two push-pull tubes attaching to a swinging beam in the rear. The control stick merely came down from the pilot's hand, attached to the cabin structure, and was pivoted to the structure below. As we built and assembled the aircraft in the basement, we had to give careful consideration to being able to get it out of the basement, and this required additional bolted joints. This is a schematic taken from a technical paper, and it shows the line drawing of the configuration. This is the center of gravity of the fuselage, the rotor, the point of pivot, and the center of gravity of the cabin. Now, if this point up here is chosen so that when the CG of the cabin is placed at that point, the total CG will be on the rotor, then the configuration is stable. This photograph was taken of Red doing a little hangar flying, or rather basement flying, by sitting in the seat of the helicopter. In the summer of 1947, we rented this building at Wilson Field, northeast of Wichita, which is now Jabara Airport, in order to do the final assembly on the helicopter. In the summer of 1947, Dick traveled to Wichita to spend his 2 weeks vacation on the project. Here he is sitting in the seat of the S3 as it was at that time. In 1947, fall of 1947, we rolled the aircraft out completed. A lot went on before this, which we'll return to, but this shows the features of the aircraft. The rotor was a flapping hinges were needle bearings on the center of rotation. On the outside of the needle bearings were plane bearings that provided for the coning. The fore and aft control was shown here, moving the cabin. Lateral control was the same, and of course they could be combined in any combination. It's a very simple control system with no feedback from the rotor. The rotor had collective pitch only. The rotor hub was a flex beam type, probably one of the earliest, in which we twisted a sheet metal angle to obtain the pitch motion. Notice the external weights on the leading edge of the blades. This is the tail rotor clutch control. Tail rotor pedals moved the control which fed back to the collective on the tail rotor, and the low pitch end disengaged the clutch for auto rotation, and once the engine was stopped, the rotor could be braked with this against the clutch to stop it. The tail rotor also used the blade attaching angle, and the blades were spring-loaded in coning to keep them away from the tail boom during starting and stopping. Tail rotor gearbox was a modified hand grinder right angle gearbox. This is a turntable with a club installed on the rotor. It's a very handy device. Here I'm practicing directional control, and of course with the tail rotor removed we could use it to calibrate the engine by a rope running off to the side, as you can see here, and it runs over to a spring scale which measures the force on the tail boom or the torque of the main rotor. This was the first liftoff in September of 1947. The ship was restrained in all directions. There was a beam off of the front that was pivoted and one off the side that was pivoted, and slack ropes to keep it from rising too far. Here it's in flight with 1 degree of freedom. There's a beam extending off the right side of the ship that's not visible in this shot and pivoted on the end. This is in slow motion. Now this allowed the ship to move fore and aft and to pitch fore and aft, and gave me an opportunity to learn how to run the fore and aft control. Turntable was used for directional. This was fore and aft. And by extending the beam off the front of the ship, I could fly the lateral control. The problem came when I tried to put them all together at one time. Starting was with a rope starter attached to the cooling fan. Cooling fan is a centrifugal type fan mounted on the engine crankshaft. It's running here. And we had a zipper fabric type cowling that enclosed it. Here the fan is inflating the cowling. Now the clutch, of course, is engaged by moving the rudder pedal, bring the rotor up to speed. Here are the simplifying features of the S-3 helicopter, some of which have been covered in the movie. We'll summarize first the movable cabin for longitudinal control, the clutch in place of the freewheeling unit, the blade attaching angle, which provides a flex beam type rotor support, blade support, automotive transmission gears, and a supercritical tail rotor shaft. Looking down on the rotor hub, we see the hub castings, two of which pivot on the center rotation for flapping and coning. The blade attaching angle is attached to the hub with bolts. The vertical flange of the angle shown here, and this is the horizontal flange. It's merely a piece of sheet metal bent into an angle shape. This is free to twist about the vertex of the angle, the shear center, to accommodate pitch change. At the blade end, the blades are bolted onto the angle, and a torque box extends to the rear, where the blade pitch horn comes on into the center rotation and picks up a push-pull link to a walking beam and down through the mast with a collective control. The transmission components shown here consisted first of the lower case. This was a welded steel assembly using steel sheet, plate, and bosses, and then the final machining was accomplished after it had been welded together as an assembly. The mast supported the ring gear, and of course the rotor on the upper end. The ring gear was supported to the mast with a plate and a cone. There was a needle bearing in the lower case and one here in the upper case. Thrust bearings were used below the needle bearing to carry the lift load. This case was very satisfactory and a good way to make a single unit. Probably was a few pounds heavier than it would have been in a casting. The 13-foot length of tail rotor shaft that ran the length of the tail boom operated between the first and critical speed. At low speeds, the shaft would run true. As it went through the first critical around 900 RPM, it would fly out in the middle. There was a damper there to absorb energy and hold the deflection within safe limits. At higher speeds, of course, then it would run straight again and would be completely free of the damper. The idle speed was slightly above the first critical, and the operating range was well below the second critical, where it would take on an S shape. The shaft between the engine and the transmission carried a pulley that drove through a belt to another pulley on the front of the tail rotor drive shaft. Tension was maintained in this belt with a bearing spring-loaded downward of the structure. This shaft extended back to the front of the tail boom and operated below the first critical speed because this was a short extension. The tail boom shaft, 13 foot in length, ran from a bearing in the front of the tail boom through the full length of the tail boom to the next bearing in the gearbox. There was a universal joint at this point and another universal joint between the shafts at the front of the tail boom. In the center of the long shaft was a protective sleeve bonded over the tubing, the shaft tubing, and surrounding that was a damper plate made of nylon and spring-loaded against a bulkhead. The hole through the damper was oversized, so when the shaft flew out in the middle as it went through first critical, it struck the damper, and the damper absorbed energy and held the deflections within limits. Now, this configuration, the tail rotor shaft ran at tail rotor speed, and the tail rotor gearbox had a 1-to-1 gear ratio, which meant that the shaft was running around 1700 RPM. It proved to be a very satisfactory system, was used on the S-3, the S-4 helicopters, later on Cessna helicopters, and the Hughes helicopter company adopted it and used it on their helicopters. It's lighter and less expensive and provides a very satisfactory drive. that we started with an electric starter that was powered from the battery in the truck. This method wasn't used a lot because the rope starter works so well. We're now going to take a view of a series of shots here that were taken as I progressed with my training on the helicopter flying. Now remember, this is an experimental control system flown by a pilot that had no previous experience, except for the training aids that we had looked at earlier. The safety man, Red Lubin, in front can grab a hold of this beam that extends forward and physically roll or pitch the aircraft. The training wheels, as we call them, extended out to the side on a 2x4. And the purpose of this was to assist the pilot if he came in with side drift to avoid rolling over. Learning to fly any helicopter, the pilot is always a little bit behind, tends to over-control, and it takes practice before you get to where you can control it. This control system worked very well in the air and was stable, didn't have any feedback forces, but it had some other problems we'll talk about. The helicopter weighed about 550 pounds empty, and with me in it and fuel, it was up around 800 pounds. We spent about $3,000 in the development up to the time that we incorporated. All of this flying was done with the permission of FAA. I had taken a written and physical examinations, had a student permit which stated that I had the right to teach myself to fly, probably the first time that FAA had issued such a certificate with the pilot and the instructor being the same individual. The purpose of this flying, of course, was to gather enough information and publicity to promote stock sale and get our Seibel Helicopter Company started. I never did fly with the safety wheels removed. I never did get enough confidence to get out and fly it without this safety equipment. I logged a total of about 8 hours of flying, and since it was perfectly legal flying, it applied to my solo time when I did finally get a license about 10 years later. All of my flying in the helicopter was with the CG type control. Now this proved to be unsatisfactory on 2 accounts. It wasn't enough control, and then when you came in and landed, you had all of your weight right in your hand. If you had a little side drift, the cabin would tend to move right out of your control, and this could cause the aircraft to roll over. So we converted the machine to a cyclic pitch after about 8 or 9 hours of flying with the cabin control system. Photographs and a complete written description were released to the press. Aviation Week ran a 3-page article with photographs in the November issue 1947. This publicity was very helpful in promoting the sale of stock in Seibel Helicopter Company. This article appeared in the Aeroplane magazine in December of 1947. The cover story in Mechanics Illustrated with about a 3-page spread on the inside of the magazine. Air Trails magazine and Parade magazine. With this publicity, we were able to form Seibel Helicopter Company and sell about $30,000 worth of capital stock. This is the first flight with the aircraft equipped with cyclic pitch. The pilot here is Bob Elliott. Bob was with us for a little while. He was an experienced airplane pilot, but had very minimum time in helicopters, only some dual instruction. On top of the rotor is a cyclic pitch tube that comes out the top. We'll explain that a little later in detail. Bob didn't have any problem flying the aircraft with a cyclic pitch, and I acted as a safety man, but I didn't have to do very much. With this configuration, both the collective and the cyclic pitch came up through the center of the mast. During this period, we continued to promote Seibel Helicopter and sold additional stock. This is a sketch of the transmission and the lower control assembly. This is a transmission. It has a hollow rotor shaft. Extending out the bottom of the rotor shaft is a collective tube, which has a ball bearing and allows collective input up and down. In the center of the collective tube is a cyclic tube, which comes down with an arm out to the side, extending out through a slot in the collective tube. This arm is connected with a link to another arm on the spindle. A universal joint carried by the collective tube supports the the outer portion of the spindle. A cyclic input from lateral or longitudinal tilts the spindle about the universal joint center and causes this arm here to move in an inclined circle. And the link then, of course, reciprocates up and down, as does the cyclic tube in the center. We'll move in now on the spindle. You can see the ball bearings here. The center portion of the spindle is stationary. The outer portion rotates, and this causes the cyclic tube to reciprocate up and down inside the collective tube. At the top of the rotor, this is the rotor mast. Out from the top of the rotor mast extends a collective tube, and out from the top of the collective tube, the cyclic tube. The cyclic tube has an arm that extends to the side and a pivoted link down to a walking beam, which is pivoted in the center on the collective tube. With this arrangement, motion up and down of the cyclic tube creates a reciprocating tilting of the cross arm. Motion of the collective tube up and down lifts the whole assembly up and down, so that collective input is the same on both lengths and cyclic input is opposite on the two lengths. The blade attaching angles that support the blades to the hub create a restoring moment, a spring action tending to bring the blades into flat pitch. A portion of this moment is offset with a centrifugal weight located above the walking beam and attached to the walking beam with a bipod. As the rotor rotates and with cyclic pitch this cross arm is rotating in a plane of rotation that is inclined to the rotor. This weight, of course, is rotating with the cross arm, and the center of gravity of this weight rotates in a circle up here at twice rotor speed. This creates centrifugal force outward and offsets a major portion of the spring action from the blade attaching angle. Now we'll demonstrate the control motion on the helicopter. This is cyclic pitch input with a cross arm tilting, counterweight on top. Now the collective input. The whole assembly moves up and down. There's Johnny Gibbs flying in front of our new hangar, which was twice the size of the original one. We got the airport to enlarge this in order to do our S4 development. Johnny Gibbs had an extensive background in flying helicopters, mostly in crop dusting, and joined us when we formed the corporation and all could go on a salary. The S3, early in the development of the S4, until we had the S4 developed, and we didn't really do any additional development with the S3. It was just for demonstration and promotional purposes. Father was in the oil business in Wichita, and he brought out a lot of his friends in the oil business, and they invested in the company. A major portion of our capital investment was from the oil industry. This is my father here, Dick Ledwin back here, and Joe Aylward, who was our biggest stockholder. In addition to many private demonstrations, we had a public demonstration one Sunday afternoon. We ran an article in the newspaper, a local newspaper, stating that we would be flying a helicopter on demonstration at Wilson Field, and that people are welcome to come for the demonstration, no charge. And we had about a third of the airport covered with cars and people. There was indeed a lot of interest in helicopters because of the novelty, and people had never seen one before. Many of them hadn't even seen pictures of them. The feature attraction of El Dorado's Christmas party was to have Santa Claus fly in a helicopter. El Dorado is a small city about 50 miles from Wichita. Preliminary to the fly-in the ballpark in El Dorado in 1948, Santa tried out the helicopter. Johnny Gibbs proved to be just as good a Santa Claus as he was a helicopter pilot. Went off real well. These shots were taken preliminary to the visit for publicity purposes. The December issue, 1948, of the American Helicopter magazine featured a photograph taken of Santa flying the helicopter on the front cover of the magazine. December the 20th, 1948 was a dark, wintry day in Kansas, but Santa Claus arrived right on schedule to the ball stadium in El Dorado, Kansas. We had a good crowd. In fact, the stadium was almost filled and people standing on the field. Santa put on a demonstration for everybody, since most of them had never seen a helicopter. Johnny Gibbs was a good Santa Claus. He greeted the crowd. And then when he stopped the helicopter, we let people come up to it. This Governor Carlson, who came in from Topeka, I'm escorting him out. He seemed to be interested in helicopters, or perhaps voters, because he showed up at places where they had big crowds like this. We then let everybody come up and look around. Of course, we had to stand by, make sure somebody didn't chin themselves on a tail rotor. I had lots of questions. This is Red Lubin, standing by the machine, John Miller. And my father over here. My son Dave, who is 3.5 years old, couldn't understand why Daddy was letting Santa Claus fly his helicopter. This is Dave. Early in 1949, we decided to discontinue flight operations with the S-3. This little helicopter had investigated 6 innovative ideas, two-thirds of which had been successful and were carried forward into future designs. It had been the primary tool to promote Seibel Helicopter Company. It had flown about 100 hours by 3 different pilots, one of which was helicopter rated. It had not been damaged or involved in any accident, but it had served its purpose. We offered it to a couple of museums, but at that time it had no historic value, so it was dismantled and hauled off to the scrapyard. The S-4 helicopter was a 2-place with approximately twice as much power and twice the gross weight. CAA certification was sought on this model from the beginning. This is a side view line drawing of the S-4 helicopter. The fuselage was a welded steel tubular frame. The tail boom to the rear was a sheet metal construction. The pilot station was well forward, and a generous cargo bay was available below the rotor on the center of gravity, which could be loaded from the rear or loaded from the side. The landing gear is a wheel tricycle type gear. The engine was well aft, drove through a centrifugal clutch, a freewheeling unit, 2 universal joints, and a sliding spline into the pinion in the transmission. The ring gear in the transmission drove the rotor shaft. The ratio was 6 2/3 to 1. The rotor diameter was 29 feet. We're looking at the Lycoming 4-cylinder engine with the cowling removed. Above the engine is a supercharger, a Roots blower, driven directly from the crankshaft with 2 V-belts. The fan is a axial flow fan bolted directly to the crankshaft. This is the intake side of the supercharger. We're now viewing the engine from the right side. We again see the supercharger. This is the exit, air exit from the supercharger that goes down to the carburetor and pressurizes it for altitude performance. On the front of the engine, the cooling fan bolted directly crankshaft carries a drum with notches to accommodate the pull starter. On the front of the engine is the centrifugal clutch, the freewheeling unit, double universal joints that we discussed before. Here are 2 belts, V-belts, that drive a tail rotor shaft that runs back under the engine. The rotor hub on the S4 is very similar to the S3. Here is the center of rotation and the intermeshing hub parts, the blade attaching angles on each side, the mast coming up in the center, collective tube coming out of the top of the mast, and the cyclic tube here at the top with an arm to the side and a link down to the cross arm. This is a scissors arrangement that maintains the angular position of the cyclic tube. The cross arm has links that go out here to a bell crank with a weight on the bottom of the bell crank. Centrifugal force acting outward puts this link in compression, and this of course has an over-center action and offsets the force coming in from the blade attaching angle. Review of the configuration. The tail rotor was essentially the same as the S3. It's the main rotor. We used 2 external mass balance weights on the S4. The first flight on the S4 was made on a cold, wintry day in the first week in January 1949. I'm standing by on the front. Mr. Dick Ledwin on the right and Red Lubin on the left. Johnny Gibbs, of course, is doing the flying. Everything went well, just a matter of seconds while he had complete control with no problems. By the spring of 1949, we were doing extensive flying. Here you see in the cargo bay a rear seat installed. The engine was a Lycoming 4-cylinder 0235 C1 engine producing 108 horsepower, rated horsepower. This was a little marginal. The supercharger took some of that, of course, and although it had altitude performance equal to the sea level performance, the overall performance wasn't really satisfactory for a 2-place machine. Now, these shots were taken along in April of 1949, 1 year from the time we formed Seibel Helicopter Corporation and started the design and construction of the S4. On the S4, the fuel tanks were located here, 1 tank on each side with a total capacity of 20 gallons of fuel. See our company building in the background. The airport enlarged it, actually doubled the size when we incorporated. raised the rent too, of course. As we went along, we added more to the helicopter. Of course, we finally had a windshield and then a complete enclosure, which you'll see later. By the summer of '49, we were making altitude flights and we're getting into the FAA certification program. The helicopter was equipped with slip rings on the mast so we could measure stresses in the rotor hub. You can see the slip rings here. We made a thorough investigation of rotor stresses under all maneuvers, and the hub had infinite life. The blade attaching angle demonstrated excellent structural capability. On this flight, we were getting ready to make a climb to 10,000 feet, which was about the ceiling of the aircraft. The aircraft was loaded to 1,500 pounds gross weight. Here we're checking out the oscillograph, which is located in the cargo bay, but measured stresses up on the rotor system. Even though it's summertime, Johnny dressed pretty warm in this fresh air taxi to go on up there to 10,000. We had installed the supercharger because we recognized that helicopters were being used in the mountains where other types of transportation were not available, and in the mountains you need a supercharger. So we went ahead and certificated with the supercharger. It was a long wait because we didn't have radio communication, and we were out of contact with him for some time. Everything went well on these flights, and he proceeded to do all the maneuvers up there and record the stresses. We recognized this point we were going to have to increase power, but decided it was best to go ahead and get a type certificate on the S4 as initially started, and then it would be a much simpler program to increase the power later, keep the gross weight the same. Here, Dick, Johnny and I are holding our post-flight conference before the rotor stops. By the fall of 1949, we dressed up the helicopter a bit by spraying a little paint over the zinc chromate. And we moved our operations to a position on North Broadway, 5613 North Broadway. This is taken in the back of the building. And we were continuing to, with our FAA program. You notice the stabilizer here on the back. We had been discussing our program with the military, and we're beginning to get quite a few military. Our military visitors were from the Army and the Air Force. At that time, the Air Force was buying equipment for the Army. Notice the side curtains here installed in the back of the helicopter. Later on, we also made a fabric type covering for the front. Johnny Gibbs put on good demonstrations, and the word got around. We had lots of visitors that, of course, interrupted our FAA program a little bit, but had to carry on the marketing activities too. This new location was not on an airport, but we had a good open field in the back, and it was quite adequate for our flying. We were located well north of the city, and so had a lot of open country around us to do our flight testing over. We were only the 5th company in the United States to make application for type certificate, so there was a lot of interest. It was quite early in the helicopter program. By March 1950, we had completed all the requirements for FAA certification except the final board meeting. This photograph was published in the Eagle, the Wichita Eagle newspaper, and this is Sanford Hinton, who was the flight test engineer on the program from FAA or CAA, myself, Dick Ledwin, Lee Shinest, who did the flying in the helicopter for FAA, Dale Miller, who was a factory inspector, and Johnny Gibbs. In those days, the FAA was a lot different than today. It was an engineering organization, and when these people came down and worked with us on the program, it was like having an increase in our staff because they pitched in and helped with the work that had to be done. Here we see the celebrities arriving for the formal presentation of the first helicopter type certificate in Kansas at the Municipal Airport in Wichita, April the 23rd. Here's Governor Carlson arriving for the occasion from Topeka in a National Guard C-47. There were about 2,000 people in attendance at the airport. It was sponsored by the Chamber of Commerce of Wichita, and the aviation industry in Wichita welcomed Seibel Helicopter into the fold as the new aircraft manufacturing company. Here's the celebrities gathering on the stand. This was an extremely windy day. The wind was blowing about 35-40 miles an hour, as you can see on the pant legs here. This is Jiggs Miller, who was a master of ceremony at the program. Marcellus Murdoch, who is the Eagle, Wichita Eagle newspaper. This is Walter Beach, president of Beach Aircraft. Earl Schaefer, who was general manager and vice president of Boeing division in Wichita. And notice everybody holding their hats on here. This is Dwayne Wallace, who was president of Cessna. And Al Mooney, president of Mooney Aircraft. And then Henry Weeks with the FAA from Kansas City made the presentation to me of the type certificate, and we had to thank everybody, of course, for their participation in the program. In spite of the wind, we had no problem with the flying. This Governor Carlson, who was the key speaker, of course, and finished off the formal presentation for us. Henry Weeks told me, he says, I don't want you to go out there and wreck this thing in this windy day right in front of all these people after I give you a type certificate. He had his fingers crossed. Johnny Gibbs put on an excellent demonstration on that Sunday afternoon. The wind didn't bother him at all and actually improved the performance a little bit. The type certificate was presented just 2 years from the formation of Seibel Helicopter Company, so we had designed, built, and FAA certificated the helicopter in a 2-year period. We had spent approximately $80,000 in reaching this milestone, and the S-4 was the 6th helicopter to be CAA approved, and Seibel Helicopter Company was the 5th company to get a type certificate. After the flight demonstration, the celebrities gathered around the helicopter for questions and photographs. And this is Henry Weeks, FAA, Governor Carlson. With the type certificate in hand on the S4, we immediately removed the 108 horsepower engine and the supercharger and installed a Lycoming 4-cylinder 0290D engine rated at 125 horsepower. Without the supercharger load, this gave us about a 25% increase in power, and the certification went pretty fast this time since it was a minor change compared to the original program. We interested the Army in buying 2 helicopters. And this went real well because the Army was controlled by a very small number of people in the aviation end of it, but they were not considered adequate to procure their own aircraft, so the procurement went through the Air Force. Now this was another story with a big bureaucratic operation at Wright Field. They issued us a letter of intent for us to spend $10,000 in the progress on the production of the 2 ships. With the $10,000 in money we had in the bank, we built the 2 ships in short order, but still didn't have a contract. And this got to be quite a problem because we were out of funds, and even though we had a total contract for $50,000 for 2 helicopters, spare parts, handbooks, and technical service, we couldn't collect any more money till the contract was issued. There was some comedy though. One day a couple of jokers showed up from Wright Field. They were facility investigators to determine whether we could perform on the contract. They had long pages of forms, how many square feet of shop space. We had 2,000 rented. How much machine tools. We had a couple $100 worth of Sears and Roebuck home workshop equipment, and we had no money in the bank. The bottom line on their form said we can't possibly perform on the contract, but they're set the 2 helicopters, completely FAA approved, and this was the only condition to delivery. So it was a lot of fun to watch them stew around for a couple days. They finally went home. We never heard any more about it. We went to the bank to borrow money, and of course the banker won't loan you any money unless you don't need the loan. And so we had a couple of months of no salary, and finally though we got our other $40,000 and delivered the helicopters. So now we'll take a little look at this history. This is Harold Hermes with the FAA. The FAA had a reorganization, so we had a different test pilot on the S4A program. These are some auto-rotation landings in the process of developing the height velocity diagram for FAA. These photos were taken at the Crestview Country Club in Wichita. If you hadn't noticed already, note the much lower cowling on the S4A. The additional 25% horsepower let us carry passengers in good shape. I don't think this little girl had ever had a ride in any kind of a small aircraft before. So it was quite a thrill for her, especially being a wide open cabin. Of course, our effort now was to demonstrate the capability of the aircraft to all potential customers. Here the prototype is approaching the building at 5613 North Broadway, the building that we rented a portion of it, and he's coming in the front yard right by the highway. The observer in the back, you'll note, is facing aft. Seat could be installed either way. Now we're around behind the building. It wasn't near as nice a place to fly from as the airport, but the facilities in the building were much better. This is observer's view of the building from the air. And you notice the highway along here is North Broadway. Now the observer's facing forward. This is a demonstration of carrying a litter, single stretcher. Note the side curtains on the rear compartment here. And of course the door was merely a zipper. These snapped on and came off quite quickly if you wanted to use it either enclosed or open. This is a wire laying demonstration. We had a reel in the back of the helicopter with wire on it. This is not the type of equipment the Army used, but it's all we had for demonstration. We used electrical starter, external starter plugged into the truck. It was very effective in starting a helicopter, but still wasn't used a lot because the rope starter works so well. Johnny Gibbs was a crop duster pilot with a helicopter before he joined us, and occasionally he liked to go out and do some of his old maneuvers at low altitude and put on a demonstration. Neighborhood dog here just wasn't approving of what he was doing. Actually kind of hard to keep up with him with a camera on some occasions when he made these sudden turns and came diving back in. It's Major Hill, Jim Hill, and Captain Gaddis, who visited us from the Army and flew the prototype. This was after we had a contract. Here's Captain Gaddis flying. Strictly a familiarization visit. He was a very professional test pilot. They were both from Fort Bragg in North Carolina, which was the Army's test center at that time. We were working on the two helicopters for the Army, which were the YH-41, or I'm sorry, YH-24. The H-13 was the Bell. The H-23 was a Hiller. Of course, H-19 was a Sikorsky, and this is the YH-24. Hugh Gaddis didn't have any problem in taking over and flying immediately. Now this is a flight acceptance flight, and since the Air Force was a procuring agency, they did the acceptance flying, and this is Lieutenant Wayne Eggers making the acceptance flight on the first helicopter. You notice that we provided side curtains on the rear and also over the pilot's enclosure, so you could enclose the complete helicopter with side curtains, kind of like the old Model T Ford. Wayne had no problem in getting accustomed to the helicopter immediately, conducted his acceptance flying with no difficulty. This is a Colonel Gottfried, and that's Mr. Merritt in the blue coat, Red Lovin, Dick Ledwin, and this is Captain Moore. Wayne Eggers flying again. Johnny Gibbs, our pilot. The pilot's enclosure worked kind of like a baby buggy top and swung back. Phil Hatfield was our helper in the shop. Jack Marinelli here was very instrumental in us getting our contract, Colonel Marinelli. He was with the Army and wanted to look at all possibilities on the helicopters. This is Gottfried. He wasn't anywhere near as good a pilot as Wayne Eggers, and I never did get him turned loose, really. I never got enough confidence to really step back and let him take over. So he'd get into an oscillation that needed to be damped out. It was their helicopter at this point, so they could fly it if they wanted to and put anybody in it they wanted to put in it. We'd do all we could to help them. The disadvantage of having just a single controlled helicopter, of course. Now this is down at Fort Bragg, North Carolina, and this Captain Gaddis again. He was a project pilot. I don't know why pilots like to make these hovering turns in this helicopter, maybe because they set forward so far that it was somewhat of a thrill, but it seemed like all of them that got in it would go out there and spin around like a top. Captain Gaddis was an excellent pilot. I got to know him real well during the Fort Bragg evaluation. Here the YH-24 is taking its place on the flight line. This helicopter on the other side is Sikorsky's S-52. It was on evaluation at the same time. Here we have a wire cartridge for wire laying, and this is Major Haynes flying the helicopter. Here's a wire container, which was just a coil of wire that came out from the center of the coil in the back. The way the Army did it, and of course a much better arrangement than the reel we had used. They weren't actually doing any wire laying here, but they had been doing it, and it was installed in there. One helicopter was at Wright Field for evaluation by the Air Force, and the other one at Fort Bragg. The Army people did far more evaluation and work than the Air Force. Having delivered the YH-24 helicopters in April of 1951, we followed the program of tests very closely. We realized right away that we had one serious deficiency in the design of our machine. It could not be used as a trainer. We decided to modify the prototype and that had served us so well on the S4 and S4A programs, and make the S4B, which would have side-by-side seating and an increase in power. We configured this machine and took it to Fort Sill, where we demonstrated it to the Army's aviation school. We built the S4B in a couple of months during the summer of 1951, and it had the 2 seats in front with dual controls. We replaced the wheel gear with a skid gear, ground handling wheel back here. The engine was changed to a 6-cylinder Franklin, which had a displacement of 330 cubic inches and produced 165 horsepower. The same cooling fan was used on the front of the engine. In the S4B cockpit, here are the 2 seats. This is the collective for the right station. These are cyclic sticks for the 2 stations. The aircraft had an electrical system and a starter. Electrical switches are in the center console. This is the ignition switch, the instruments, and then on up at the top was the compass. This over here is a communication antenna. Before proceeding with 165 horsepower installation, we reviewed the drive system. This is the transmission. This is the pinion gear here that goes in and mounts in this part of the case. The case is a cast aluminum case. And this is the ring gear carrier, and the mast. The bearings for the bottom of the mast are in this position here. The gears used in a 1.5 ton Ford truck rear end. The ratio is 6 2/3 to 1. And we had used these on the S4, the S4A, and made many teardown inspections. They showed no sign of distress, and so we proceeded. A thorough inspection was also made of the tail rotor drive system. This is the tail rotor shaft coming from the tail boom, drives in through the shafts and seals and bearings. The input pinion gear here, and it mounts in this part of the cast gearbox. This is the output pinion with bearings and seals, and the shaft that goes out to the tail rotor. This is an extension to get the tail rotor out away from the tail boom. We found all these to be in excellent condition. There was no reason not to increase power. The tail rotor used on the S4 and the S4B was also, or S4A was used on the S4B. Here's the blade attaching angle, and the gearbox that we looked at in exploded view is here, and note the oil filler at this point with a dipstick. By the summer of 1951, we had some change in personnel. This is Jack Coleman on the left that we took aboard to help with the business and marketing activities. Dick Ledman, myself, and Jack Zimmerman, our new test pilot. Of course, this red lubbin on the end. We loaded all the paid employees of the Seibel Helicopter Company into the S4B prototype and took off and hovered. This was about 900 pounds of people. Dick Ledwin and Jack Coleman, Red Lubbin, Jack Zimmerman, and myself. The installation of the 165 horsepower engine moved the S4B into a high-performance category. Here, Jack Zimmerman and I are doing a bit of flight testing prior to showing off the helicopter. We hired Jack from a job up in Alaska. He wanted to get out of Alaska. We obtained permission from Army headquarters to take the helicopter to Fort Sill and get an evaluation by the school there as the use of it for a trainer. They were very receptive, and quite a number of their instructors flew the aircraft. We only spent one day at Fort Sill, but they were expecting us, and the program was well organized. We flew most of their instructors. The S4B still had an adequate cargo space for most of the utility missions and could actually carry an additional person back there if we would install the third seat. This was an air intake hose we ran up front to get cooler air. That could be rerouted quite easily, of course. After we returned home, we had a number of visitors drop by to see us. This is Jim Knox, who was the civilian instructor at Fort Sill, but he wasn't there the day we were there, so he came by on a vacation trip and dropped in and took a flight. At this point in time, we'd moved out of the big building and we were down in the 3400 block on North Broadway. Didn't have a very good facility. Our airfield was right among a bunch of grain elevators. Jim Knox was a good booster for us. We thought it would make a fine little trainer. We received a letter from the Artillery School Air Training Department, Fort Sill, Oklahoma, dated the 25th of October, 1951. The letter read as follows: "We wish to express our appreciation to you for the opportunity of testing your Model S4B helicopter. This helicopter was flown by our most competent helicopter instructors under varying conditions, and their reaction ranged from favorably impressed to enthusiastic. We were directed by the Army Field Forces to submit a report on the initial evaluation of the S4B helicopter. Pertinent parts of that report have been extracted and are attached for your information." Signed by Erdy D. Langsford, Lieutenant Colonel, United States Army. We were very encouraged with the reception we received on the S4B at the Army Training Center. It looked like finally we had zeroed in on a product that they would be very interested in. It needed, of course, an additional covering over the cabin, and the CG range was a little bit marginal. An increase in cyclic pitch would have taken care of this, and of course it would have to go through the FAA or CAA certification program again. The problem was we were running out of money, and we just didn't have the finances to hope to complete such a program. The climate for selling additional capital stock was not good. It was about this time that I received a call from Dwayne Wallace, president of Cessna. Dwayne knew what was going on in the industry, and I was surprised at how familiar he was with our program. He invited me out for lunch and said he had a matter he'd like to talk to me about. The gist of the meeting was that Cessna wished to buy Seibel Helicopter Company. I told him that I favored this and that I would call a directors meeting, special meeting, and I'd give him an answer in a couple days. So we negotiated for a month to 6 weeks, and the final decision was that there would be a stock exchange between our stockholders and Cessna, wherein our stockholders would agree to the plan, place their stock in escrow, and once there was 80% agreement, Cessna would then exchange Cessna stock for the Seibel helicopter stock. If they sold their stock immediately, they get their money back. Those that hung on to it saw the Cessna stock split and split again and split again. The 50s were the golden years for Cessna. By mid-December of 1951, we had the required stock, and in January 1952, the news release was made. By that time, we had 98% concurrence by the Seibel Helicopter Company stockholders. The Cessna House paper, the Sesquire, carried a complete story on the acquisition of Seibel Helicopter Company in its next issue. The S4B helicopter remained in flight status for several months. The purpose was to familiarize the Cessna personnel with helicopters, and a lot of people flew in it, and we showed it to the manufacturing people, and it was a good tool to get started with. Cessna decided that they would not pursue the S4B as a product and would start over with a larger machine. This perhaps was a mistake, because they were experts in the sheet metal construction and could have added a low-cost sheet metal structure to the well-proven dynamics of this helicopter and provided a ideal trainer for the military at a substantial reduction in price. And this would have eliminated the conventional appearance of the aircraft of being $29 worth of bad plumbing. These are the directors of Cessna. This is Frank Betker, who was Vice President of Finance, and Don Flower, who was Vice President of Marketing, Del Roscom, Vice President of Manufacturing, and Tom Salter, Vice President of Engineering, and Dwayne Wallace, President and Chairman of the Board. Frank Betker, Don Flower, Delbert Roscom, Tom Salter, Dwayne Wallace. Seibel Helicopter Company had been in existence for about 4 years, and Seibel Helicopters had been flying for about 5 years by a wide cross-section of pilots. There had been a couple occasions on hard landings where the aircraft was damaged slightly. In all cases, these were repaired and returned to service. Nobody was ever injured in the operation or flight of Seibel helicopters. In an endeavor like this, one should look back and say, what mistakes did we make? I guess the obvious one in Seibel helicopter history is that we underfinanced the company, probably by an order of magnitude. The other thing that would have been very helpful would have been to have an individual in our organization that was familiar with the contractor's side of military procurement. We spoke of the disposition of the S-3 helicopter. The S-4 helicopter was flown for a few months at Cessna and then disposed of. The two Army helicopters were a liability for Cessna. They requested that they be returned, bailed back to Cessna to be consumed in a research program that we had with the Army. This was done and they scrapped them out as soon as they received them. Well, folks, that's the helicopter story, Seibel helicopter story, which leads directly into the Cessna helicopter program, and that will be a subject of another video presentation. I'm Charlie Seibel.